Testing. Okay, so we have these three equations. You can probably see that we can easily eliminate x, say between the first two equations, if we add -2 times the second equation to the first. And then it's easy to eliminate x with the third equation, but the easiest way to start this, in this case, since we have just a plain x down here, is to write this third equation first. Okay, now the equations are 4x minus 3y plus 7z equals 8, 2x plus 4y minus 6z equals 0, x plus y plus z equals 3. I numbered those equations 1, 2, and 3 with circled numbers so we don't confuse them with numbers that we're using in the equations. Okay? Just keep track of which equation is which. So I have the three equations written with an underline, and then I write 3 with a circle, meaning I take equation 3 from the previous step and write it here. Okay, and that'll be the first equation in my system. And then I'm going to write equation 2, could be either equation 2 or equation 1. And then equation 1 is 4x minus 3y plus 7z. Uh-oh, I wrote equation. I've been doing that a lot. I started writing out the second equation, then my eye shifted to the first. So anyhow, I write equation 3 from the previous, x plus y plus z equals 3. I write equation 2 from the previous, which is 2x plus 4y minus 6z equals 0. And then I write equation 1 from before, which is 4x minus 3y plus 7z equals 8. Now that I have the equations in this order, I'm going to write down equation 1 from the previous system. In the previous system, had x plus y plus z equals 3 as the first equation. It had a number circled 3 in front of it. That's because it was equation 3 from the previous step. But now it's equation 1, equation 2, equation 3 in order, no matter where they came from, okay? So equation 1 of the previous step is x plus y plus z equals 3. Now I want to eliminate x from the other two equations. So what I do is I do equation 2 minus 2 times equation 1. That means equation 2 from the previous step minus 2 times equation 1 from the present step. When I do that, it's often a good idea to jot down my calculations somewhere. We don't want to jot anything down here because we want our system to develop in a way that we can follow it. So we don't want to do a bunch of side calculations in the middle of all this. So we come off way off to the side. I'm going to come way over here. Okay. And I'm going to write equation 2 for this step, which is 2x plus 4y minus 6z. And I'm going to write minus 2 times equation 1. Equation 1 is x plus y plus z equals 3. So I'm going to do negative 2x minus 2y minus 2z equals minus 6. And incidentally, equation 2 had an equals 0 on it that I didn't say. 2x plus 4y minus 6 equals 0. Now, when I add these equations, the 2x adds the negative 2x and gives me 0. 4y and negative 2y give me plus 2y. Negative 6z minus 2z is minus 8z. And 0 minus 6 is minus 6. So this is the equation 2 minus 2 times equation 1 in my third step, okay? By first step, I mean the three original equations. Second step, the three original equations reordered. The third step is going to be the three equations modified to eliminate x, okay? So I have 0x plus 2y minus 8z equals negative 6. Then I want to eliminate x from the third equation in my previous step, which is 4x minus 3y plus 7z. And what I'm going to do is I'm going to do the third equation in the previous step minus 4 times the first equation. So here's equation 3. 4x minus 3y plus 7z equals 8. And negative 4 times equation 1. Equation 1 was x plus y plus z equals 3. It's easy. We're going to get negative 4x minus 4y minus 4z equals negative 12. So when I add those, the x's again add up to 0 minus 7y plus 3z equals negative 4. Now, this is very similar to what you did with two equations and two unknowns. It's just that you have more variables to eliminate, okay? So we eliminate all the x's and we get, okay, now we've got 0x minus 7y plus 3z equals negative 4. Now I've written out the 0x in these last two equations, but I don't really need it. So I'm just going to go ahead and erase the 0x. So we can clearly see that what we've got left now is two equations and two unknowns that we already know how to solve. Okay? So I'm going to put 3 dots. Then we get y equals 1 and z equals 1. Now, you can solve those two equations. You just use the methods that you used in doing the homework. Okay? But eliminate y. We do 7 times the 2y minus 8z equals -6 equation, and 2 times the -7y plus 3z equals -4 equation, which would give us 14y here and -14y here. We would then add those two, and we get an equation with just z is an unknown that's easy to solve. And that hopefully that's familiar to you. If it isn't, say so in a little while after I've solved this. I'll run through that solution. But now if we got y equals 1 and z equals 1, well, if you eliminate y from these last two equations and solve for z, you're just going to plug that value of z back into this equation and get your value of y, right? So if you eliminate y from these two equations and solve for z, you're going to get z equals 1. If z equals 1, then you can plug that in here. You're going to get 2y minus 8 equals -6. 8z is just going to be 8. So it's 2y minus 8 equals -6. We add 8 to both sides. We get 2y equals -6 plus 8, which is 2. 2y equals 2, and you get y equals 1. So whether you understood all of that right away, that's exactly what you would do. Okay? I'm pretty confident you would do it. Okay? So now we're stuck with substituting y equals 1 and z equals 1 into an equation. We don't want to substitute it into one of the equations that we got after the first step. We want to substitute it into one of the original equations. Now, it turns out that we still got the original equation. It was equation 3 in the first set, then it was equation 1 in the next two sets, okay? We're still going to think of substituting these numbers back into the third equation of the original set, just in case we copied something down wrong. And we want to go back to the original equations. So we plug these numbers in. To this equation, which gives us x plus y, but y is 1, plus z, but z is 1. Now that's a tricky equation to solve, but I believe you could handle it. You're going to get x equals 1. Okay. Then you plug x equals 1 back into each of the other two equations and see if they work. Okay, that completes your check. If the solution x equals 1, y equals 1, z equals 1 works in both of these other equations, then you know you've got a good solution, okay? And it does work. It's easy to check because I chose 1, 1, and 1 for various reasons. Made it really easy for me to make sure I wasn't making a mistake, okay? Somehow I managed to do it without making a mistake. So that's the basic process. Now, I'm going to erase these scratches over here. Use water to get rid of them. Yeah, a little bit in there. Among other things, the cleaner makes the board dry. Okay, we can solve the same system using augmented matrices. So the original system, 4x minus 3y plus 7z equals 8, would be represented in an augmented matrix just by the numbers 4 -3, 7, and 8. Second equation, 2x plus 4y minus 6z equals 0, is represented by the numbers 2, 4, -6, 0. And there's nothing magical about this. It's just that whatever the coefficient of x is, it's going to go first. Whatever the coefficient of y is, goes second. Whatever the coefficient of z is, goes third. So our third equation, x plus y plus z equals 3, is just 1, 1, 1, 3. And again, we'll number the rows of this matrix 1, 2, and 3. And I'm going to do exactly the same thing I did with the equations. I'm going to put 1, 1, 1, 3 row first. Then the second row, which is 2, 4, -6, 0. And the first row, 4, -3, 7, 8. So the previous third row becomes the first row. The previous second row stays the second row actually. And the previous third row previous first row becomes the third row. And now we do identical steps. We do our first row, in other words, row 1 from the previous matrix, stays the same because we've got a 1 right where we want it, in the upper left-hand corner. And why do we want a 1 there? For the same reason we want an x here. It makes it easy to eliminate the x's below it. Then we're going to do row 2 minus 2 times row 1. So row 2 starts with a 2. In row 1 of the previous matrix, we have a 1. So minus 2 times 1 is -2. We add 2, we get 0. And then you do minus 2 times the 1 in the second column, which gives us -2. And we add that to 4, which gives us 2. Follow me? Okay. And then we add -2 times this 1, the 1 in the first row, first row, third column. That's going to give us -2, and we add that to the -6 in the third column of the second row to get -8. And then we do -2 times 3 in the first row, add that to the number below, which is 0, and we're going to get -6. Now these are exactly the same coefficients that we got when we did the elimination, writing out the whole matrix, or the whole equation. Then we're going to do row 4 minus 4 times row 1, and without quoting and doing everything, 4 minus 4 times 1 is 0. -3 minus 4 times 1 is -7. 7 minus 4 times 1 is 3. 8 minus 4 times 3 is -4. Now I look over at my equations. Now, if I'm doing augmented matrices, I'm not going to have done the equations in most cases, except when you're beginning to learn it, so you make sure you know how they correspond. So I'm just going to have the augmented matrix. I'm not going to be able to check with my equations. And actually, it looks like I got something wrong. Oh, never mind. I'm looking at the wrong side. Okay, got it right. Okay. Now, the next thing I do is a little different. I said, go ahead and solve equations 2 and 3 because you already know how to do it, and I told you what you're going to get. We're going to see how that comes out of the augmented matrix now. Okay, so I like my row 1. I like the way my row 2 starts with a 0. Okay. But then I've got a 2 in row 2 of the previous matrix. I want a 1 here. So I'm going to get a 1. How am I going to get a 1 when I've got a 2? Well, I divide by 2. So I take my previous row 2 and divide every number by 2. Okay, so the numbers are 0, 2, -8, -6. Dividing those by 2, I get 0, 1, -4, and -3. And I'm going to then write down my third row from before. I'm not going to mess with it. Next thing I want, in my third row, I want a 0 where that -7 is. You see how that works out when I do it. Okay, so row 1 is the same as in the previous matrix, 1, 1, 1, 3. Row 2 has become 0, 1, -4, -3. And row 3 is going to become times 3 plus 7 times row 1. Row 3 plus 7 times row, and it's not row 1, it's row 2. And if you look at row 3, we've got -7, where we're going to want to have a 0. That's our whole goal, is to get a 0 in the third row, second column. We have a -7 there. If we add that to 7 times the number in row 2, we're going to have 0. Okay? So -7 plus 7 times 1 gives us -7 plus 7, that's 0. Now, we're also going to have to add 7 times -4 to 3. Well, 7 times -4 is -28, added to 3 gives us 25. And we better get 25 in the next row. Okay. Now, what's 7 times -3? Oh, hold on. I said 25, it's -25. Okay, now, then we do 7 times a -3 at the end of the second row in the previous matrix, and add that to -4. 7 times -3 is -21, and -4 gives us -25. And then we're going to be in upper triangular form if we just get a 1 here. In the third row, third column, we want a 1. We've got -25. So it's real easy to get that. I'm going to label process over here. I take row 3 of my previous matrix and divide it by -25. It's pretty clear that I'm going to get 0, 0, 1,